Okay, we are now live on YouTube. I'll share the YouTube link with everybody in the chat right here. And let me go ahead and share my screen really quickly. Welcome everybody to GraphQL Contributor Days. While I struggle with this screen. Oh, there we go, found it. Okay, so very excited to have you all here today. This is an event we do every few months, and it's so amazing because, you know, I think we all miss the conversations that we're used to having at conferences. So it's so great to bring everyone together. Thank you everyone for joining today. Wanted to give a quick shout out to our sponsors. Pass it off to the Hasura folk. I don't know if Tyler or Tom, I want to give a little shout out, but thank you so much for sponsoring and partnering for the past couple of years with GraphQL Contributor Days.
Hey folks, I'm super happy to be helping out at this event, and this has been a part of our series that we've been doing regularly over the last, I think, almost 1.5 years now. So exciting to kick this off for 2021.
Yes, I feel like it's actually been longer, probably. Yeah, and you guys have been awesome, so thank you. Wanted to also thank my company, the Labs. So we have a labs portion of our company. We're about a team of 50 developers right now. We are growing. So if you want to come work on just fun projects, we just do a lot in JavaScript. So come hang out. You can always email me or message me on Twitter at LadyLeet or Tracy@thisdot.co. But yeah, it's really cool. We're building a really fun, inclusive team here. I love it. We have a lot of really amazing events coming up as well. So things to look forward to. We have State of Application Monitoring coming up on 4/20. Every month we do a monthly mentoring for women in tech. So that's April 21st as well. Come hang out for an hour, you know, whether it's you wanting to mentor or whether it's you wanting to get advice. React Contributor Days is co-hosted by myself and Kent Dodds. That's going to happen May 13th. Some really amazing topics and planned agenda there as well. State of Vue with the Vue core team is going to be happening on May 20th with Evan Yu and a bunch of other folks from the Vue ecosystem kind of giving updates on their projects. And then we also have State of Accessibility, which is happening on May 25th. And that's going to be a really fun lineup too. So definitely stay tuned for all the fun stuff we have going on. Today you have 3 hosts. I'm one of them, Tracy Lee, CEO of the Labs. We also have Tanmai, CTO of Hasura, who you just heard from, and also Tyler, who's head of community at Hasura. So thanks all for joining.
Pleasure.
We also have some amazing panelists today. So very excited to have folks like Lee joining, giving us an update as well. And just a bunch of really amazing people who, you know, y'all have been just amazing folks within the community. And, you know, conversation definitely doesn't stop here. So for those of you who are listening or may not be super involved in the GraphQL community yet, all these folks are really accessible via Twitter mostly, and really nice. So part of the kind of spirit of GraphQL Contributor Days is to try to make open source more accessible and to kind of, you know, have open conversations about, you know, really cool things happening with the ecosystem. So we have a little bit of an agenda, and Tyler, I don't know if you want to, Tyler and or Tanmai, if you guys want to take it over.
Yeah, I absolutely will.
Go ahead, Tyler.
Would you mind clicking through? So unlike previous versions of this, one, we've shortened the length because we all know that the beauty of GraphQL is you build things with it. The challenge of GraphQL is there's things to be built. So we've condensed the time a bit. And what we've done is we've actually reached out to everyone who registered and asked, what would you like to discuss? And so we've begun to compress that information into the series of topics and items of interest that each of you have said are meaningful, often when there was more than one. So rather than spending 90 minutes talking about API lifecycle, we're going to spend a half hour on it. The value in this kind of event is the interaction that each of us have, and that those who are watching on YouTube are able to add comments and questions as well, which we'll keep an eye on. So yeah, we'll kick off. Tanmai is going to really host a lot of this interaction for us, but it's meant to be a time where we have a conversation, not where vendors talk at each other or etc. This is about us making the world in which we GraphQL even better. So as Tracy said, thank you so much for joining. And with that, I think that the first topic is actually diving into what's happening in the foundation. Lee, thank you so much for your time, for taking it out. I know you're super busy, mate. So thanks for taking it out to come and hang out and chat with us. Do you want to start by giving us an update of what's going on?
Sure. Yeah. Always happy to join this lovely crew. So lots of things have been happening with the foundation. We continue to grow and want to keep growing. So by the way, if you work at a company and you work on GraphQL related things, join the foundation. It's a great way to stay involved with the actual technical process, and also the way that we market GraphQL, the way that we fund GraphQL. There's a lot of the core things of how GraphQL works happens through the foundation. So we're always looking to continue to grow. Two major things that are focus points for us right now. One is getting out the next edition of the spec. So we cut editions of the spec. The goal is to cut them annually. We've been closer to about once every 1.5 years. So it's been almost 2 years since the last spec cut, and there's a ton of really awesome things between the last time we did a spec cut and this time. So it'll also be the first time we've done a spec cut since forming the GraphQL Foundation, which is exciting as a milestone, but also exciting in that it's a brand new legal process. So if you're ever interested in the wonkery of specification legal documentation, I know more of that than I would prefer to. Beyond that, there's a ton of really awesome things happening through the working group right now. I think two of the ones that have had the longest sort of tenure in those discussions have been input unions and stream and defer. There's a ton of others, but I think those have gotten the lion's share of the sort of work over the last more than year, really, but especially over the last few months. The other thing that is happening in the GraphQL Foundation, so the GraphQL Foundation obviously responsible for the technical work across many GraphQL projects. It's also a funding source so that we can pour fuel on the fire for the various things that we want to do. Not that long ago, I think maybe halfway through last year, we launched the GraphQL shop. That runs profit neutral, by the way. We just pour money into it to make it work, and we don't take any profit on anything sold there. And I'm very happy that there are bow ties there, and I've been told that the bow ties have almost sold out. So if you want a GraphQL bow tie, you gotta hit up our GraphQL store. But the other thing that we're working on is a GraphQL contributors grant. This is something that I've been focused on building for a couple of months now, and I'm getting really close to launching the first edition of. So stay tuned for the actual size amounts of those. But essentially the idea is we have a ton of people across the whole open source ecosystem who are making pretty significant contributions to GraphQL, and we want to fund their ability to do that through a grant program. That's one of the many ways that the GraphQL Foundation can use our shared resources. And probably one of the most important ways. So that's something I've been working on, and stay tuned over the next month or so as I roll out the first edition of that.
That's awesome. Thanks, Stanley, for the update. Any particular discussions or conversations that folks on the call would like to ask Lee about, or ask each other about on any specifics of the GraphQL Foundation, or any new items in the spec, or any particular items on the spec, specifically input unions, defer, stream, that folks are excited about? If not, I shall kick it off with what I have been very curious about, which is how many of you all are using defer and stream already? And what kinds of use cases are you excited about with defer and stream, and what kinds of challenges have you seen with implementing defer and stream, both on the server side and on the client side. Also, before we get to that, maybe just Lee mentioned that there's a GraphQL store, so that's on store.graphql.org. Check it out if you're listening in. But yeah, over to you folks. Anybody who's already using Dev for Stream and any experiences they'd like to share?
I know Facebook has been for a while, and that was I had built a prototype at Facebook many years back, and that's been converted into something that's actually production grade over the last year and a half or so by some fine folks there. And that's half of the crew that are championing this, which is actually really exciting. I think when I pitched it originally, it was very much a prototype, and I was a little hesitant about taking a prototype and turning it into a specification because you're never quite sure whether it's actually going to work out in practice. And sure enough, they had to make some relatively significant changes to the mechanics and the semantics of how that works in order to make sure that it would actually scale up. But my understanding is that Facebook's using this at scale now and has been for almost a full year. And they've been iterating on it and tweaking it, and that's been folding itself back into the spec. There are a handful of others that have been contributing that I know have also been using this in production. But yeah, I'm curious if anyone on the call has actually started to use this. I know it's out there in a handful of implementations as references or as an experiment. You have to toggle it on.
Yeah, I remember we implemented a version of Defer a while ago at a prototype level. We called it async. Wasn't a particularly good name. It's just like a prototype thing. But the idea was that you can kind of defer fetching certain pieces of the query, and that can come in later as over HTTP or over WebSockets both. I think one of the things there was one of the things that especially if you have insight into how it's being used at Facebook, what is kind of the developer experience around using Defer? Like who takes the call? Is it like the client side developer that they're building kind of a feature on the app and they need to they want to decide, hey, I want to make this piece deferable. Is it deferable or not? And then what does that feel like, or whether I should defer it or not? What is that kind of piece like?
Yeah, my understanding is that happens all on the client. Actually, for a server-side engineer, the stream and defer semantics are largely invisible. And the nice thing is that, so I should back up and explain a little bit about what these two things do. So defer is a GraphQL directive that you can stick on. I think the original prototype allowed it just about anywhere. I think the new proposal is limiting it to being applied to a fragment. So you can apply it to a fragment or an inline fragment. It will, as you execute, it'll look at things that are marked defer and wait. It won't immediately execute them. It'll actually, the mental model is that it's kind of like starting an execution in parallel in a separate thread. And as each of these various now forked out pieces of the query execution resolve, they can be streamed down in chunked payloads. You get the first payload comes back sort of as a traditional GraphQL payload, but it has an extra field in there that says done false, so that you know that there's more coming. And then you get additional streamed payloads that tell you the delta into the query, a little bit of additional metadata that you need to know how to reassemble it, and the data for that fragment that was deferred. Stream is similar in the sense that it creates a stream of these things, and actually the two can be used in tandem with one another. But stream you apply to a field that returns a list of things. And what that will do is it will essentially create a thread loop for each of the items in that list. So it'll resolve the first one before starting the second one, then it will do the second one before starting the third one. And so you get this stream of payloads over time for that list. And that's really useful if you have a list of things that are pretty expensive to compute and you really care the most about getting the first one back to the client first, rather than getting the full set back. So I know Facebook uses this for newsfeed, where it's really important to get the very first newsfeed story onto the page and way less important to get the 10th one there, but you still want it there. So when someone starts scrolling, they can see it there. So the developer experience is actually super nice. All you have to do is just apply that directive and stuff just kind of works. Obviously, if you're just using the most bare bones, just directly sending GraphQL queries over a raw network connection, then you're going to have to parse the payloads and figure out what to do with them and handle the events and update your UI. Facebook uses Relay, and Relay has stream and defer built in. And that allows the developer experience to be pretty smooth. It also means that you're not guessing about where you can and can't apply these things. Anything that's a fragment can be deferred. Anything that's a list can be streamed. And my understanding is that on the server side, there's actually an even more interesting integration where anything that's an array on the back end is represented through GraphQL as a list that can be streamed. And the GraphQL engine on the server will handle that. But also, if you have a server that supports streaming itself, then that will link itself all the way through. So if you say, rather than, hey, I have an array and that array is backed by, or I have a list, GraphQL list, and that is backed by an array, you say, I have a GraphQL list, and that's actually backed by a stream. In a typical execution, what it would do is it would exhaust the stream until it's done, and then it would create that array and send it back in the form of a fully formed list. But in the case of stream, it'll actually pipeline the entire thing, where as soon as the first thing comes up off the stream, it'll buffer them and then pull them out as it's rendering them. And Facebook has implemented a handful of data services that allow you to query for lists of things as a stream, and they then hook sort of all the pieces together, bolts to nuts, which is super cool. And that's something that I hope that we can get some of the open source implementations to provide similar structure. We have the base pieces for it in Node.js. This is a async generator function, which is one of the more esoteric varieties of functions, but those essentially model this property. And GraphQL.js has already used them for quite a while to model subscriptions, which is sort of another method for streaming. So that's a little bit of the developer experience. It's really nice. It's like there's a lot of these implementation details that are kind of complicated, but the final developer experience is super high level. You just apply the directive and then you see the appropriate client behavior.
Got it, and that makes a lot of sense. And so is from on the front end developer side, is almost any field deferable, or is the general idea that the API or the schema kind of exposes as many things as deferable by default, so that then developers can kind of choose whether or not to defer it, and that's kind of handled by the GraphQL engine appropriately, or how does that decision?
It's entirely handled. Yeah, it's entirely handled between the GraphQL engine and the client. So the server developer has no say in what is or isn't deferrable or streamable. Anything that's an array can be streamed. Anything that you can model as a fragment can be deferred, which is nice in that it means if any existing schema can apply stream and defer once you have a service that supports them, and without having to add additional stuff to your schema or implement anything additionally underneath the hood. And for a client, it means that they don't have to sort of guess and check as to whether a schema allows them to defer and stream something. It's purely just a function of how the GraphQL execution engine works rather than some behavior that's underneath it. But what I was mentioning before about the actual, like an underlying streaming service below the GraphQL execution engine, obviously that's only going to be taken advantage of if your service both supports those kinds of things under the hood and then also can yield them through a stream. And I know that was sort of the impetus for Facebook getting into this in the first place, is there's sort of an end-to-end efficiency win for them, and which yields out client-side performance as well. And that was sort of the motivation. So I know that's especially why it took them so long, is they had to kind of get all the pieces from front to back to connect like that. But it's nice that you don't have to rely on that. And there are cases, my understanding is there are cases at Facebook where people are streaming things that aren't actually backed by any streaming semantic under the hood. They're just purely an array, but you still get the performance benefit by doing the rest of the GraphQL execution below that point for each item in that array.
Now that's awesome. And at the risk of going down the rabbit hole now, I just have one last question, because this is what I get asked very often, which is I haven't been through the fine spec in detail, but are there error semantics as well in suppose you're trying to defer something or stream something and something couldn't be streamed, like the second payload, a third chunk or fourth chunk couldn't be sent. Is there a particular kind of error contract that's a part of the spec as well, or is kind of left to the nitty-gritties of the implementers?
It's definitely part of the spec. Yeah, error handling is super important, and you don't want to leave that up to non-determinism. I won't speak too much to it because I don't want to get something wrong, but you can imagine why the out-of-the-box event handling or error handling model just doesn't work for something that's deferred, because it assumes that error can bubble up through, and if you've deferred execution, then you got to yield something out in advance, and so the high level idea is that it creates a new top level error boundary that can catch those things. So in the top level payload, you can have that whole payload fail if you have an error that bubbles itself all the way up to the top level of that particular deferred chunk. One thing that I should say is that, and I think this gets back to your question about like what should you defer? Like you can defer anything, but what should you defer? And this is actually a case where semantically the service or technically the service has the ability to change the behavior here. Is that the server may decide not to defer something if it is smart enough to know that deferring that thing will always lead to a performance loss. It can always push chunks together and send you single chunks. So essentially applying stream and defer doesn't require there to be a certain number of network payloads under the hood. It just allows there to be. So it's like there will be a seam here, but that either that seam will happen at 2 points over time, or it might happen in 1 point over time. And so that gives the server a little bit of flexibility to say like, hey, I understand the semantic of what you're asking for, and based on all of the knowledge that I have, it's faster for me to give you this. I don't remember whether or not we ended up doing chunked streams or not, but I know that has been part of the active discussion of, if you've got a list of 10 things, do you have to send it 1 by 1 by 1 by 1, or can you send it 2 by 2 or 3 by 1 by 1 by 1? And there's some, sometimes the clients want to have some behavior over that, and sometimes the servers want to have some behavior over that. So really the end goal, and this is still a work in progress, so there's room for these things to evolve, but the end goal is for the client to describe the semantic that they want, and then the server to take that knowledge in and produce the highest performance result with that.
Got it. No, that's awesome. That makes a lot of sense. And I like the end user kind of mental model as well, which is that the developers only care about like what is deferable or streamable from a UX point of view, and they just annotate that fairly liberally, right? Because they know from a user experience point of view, this is deferable or streamable. And then the backend can take a call on deciding whether to actually defer it or stream it or not, right? So that's I think that's a nice mental model. That's awesome. I'm looking forward to this landing. Any idea on when you think this will happen?
It's hard to say. I think we're kind of in the later phases of the specification process for this one. It's been in the works for probably about a year, maybe a little bit over a year. So, which is not uncommon. I think most of the things that go through the spec process take a while, just to, everybody is busy and this is a side gig for everyone. The frequency at which we meet, the level of work and detail that are put into these things, they take time. And then also, the goal here is never to move fast, which is a little bit counterintuitive because these things are exciting and we want to use them. But the goal is to get them right, because once they're in the spec, it's really hard to change them. And so we put a lot of sweat into making sure that the things that land in the spec are the right things. So, it could be a while, but my hope is that it happens relatively soon. My hope is that the next edition of the spec includes both input unions and stream and defer. And if you think about like, oh yeah, these have been in the spec process for a little over a year. I did a presentation introducing the concepts of stream and defer years ago. These ideas sort of percolate until we kind of finally get them right, and then we send them out everywhere. But hopefully, and this is part of the reason why it's actually unlocked us to start working on this, is we really encourage other people to experiment with them. We don't want people to rely on something that might change, but we definitely encourage people to experiment. And that's exactly what has happened. And there's a handful of companies out there that have been playing around with stream and defer. And that expertise is what led to multiple perspectives on the problem that is giving us confidence in a shared direction. So there's actually like multiple companies working together on this particular proposal, which is really cool.
When you say years ago, like I just happened to look it up. It was 2016. So this is not
5
like a
years ago.
half-baked concept, right? It's something that has been well thought through, and a lot of time and effort has been put into making it both possible and performant.
Yeah. And it's not like it was consistently worked on for all that time, but it was, you know, my first prototype was done 5 years ago, and I gave a conference talk about that. And then that thing had performance issues, and I was not confident in rolling it out at Facebook. We tried to build it again purely as a client-side construct within Relay, and that was a little too awkward, and we ended up pulling it out. And then the most recent version is the one that my old colleagues at Facebook have built, that's built into the service, that's actually more thoughtfully constrained and allows good performance and clearer semantics. And so that's finally the one that's succeeding. And so credit to them to actually crack the nut on this one. So sometimes it just takes multiple whacks at the problem before you get it, even though the high level idea is clear.
That's awesome. That sounds really exciting. And yeah, a slow moving spec is ideal so that we don't get things wrong and then crash around. So that's amazing. Cool, awesome. Any other questions and discussions that folks have for Lee around the foundation, or any specific updates to the spec and stuff like that before we move on to our next topic around API lifecycle? All right. So yeah, in that, thanks a lot, Pete, for taking us over the updates, and I'll move on to kind of the next section of our discussion around the API lifecycle around GraphQL. So the idea here is to basically kind of talk a little bit about and discuss, kind of exchange notes on the end-to-end lifecycle around using GraphQL. So that's like, you know, design, build, operate, iterate, and, you know, maintain and debug, right? And interesting things that, you know, folks have been doing in different parts of this life cycle, and notes that they'd like to share. To maybe kick things off, I know that Uri and the Guild and Sean at OneGraph have been doing some amazing work in different parts of this life cycle. And so maybe if you folks want to kick things off with things that you're seeing and problems that you're solving and things that you're excited about, would love for you to kick this off.
Sean, you want to start?
No, I don't know that we have a ton of insights in here. It's kind of like an ongoing research project in a way, but a research project in production, which is always fun, where you're kind of trying to manage, you know, as upstream providers that you don't have control over, remove data from their API or change their API. How do you push changes to the client seamlessly? We're actually talking with Ink and Switch, which they released a paper called Cambria that talks, it's kind of an example of Convergent Evolution, where they're talking about, you know, your client should be able to access a data model off of a well-typed schema, and then you can evolve your schema in the same way that maybe Stripe does, where you hit an old version of an API, and internally they have a bunch of migrations. Every time you release a new version of your API, you'll transform the incoming request from the old one to the new one, and do that subsequently until you get to the latest version of your API. And then you have a downgrader for the response that goes back to their version as well. So we've been exploring that a bit, but that's still kind of pie in the sky, like ideas right now. Right now, it's like basically just a lot of manual work to deprecate fields, notify the clients who are affected, push changes to them in as automated a way as possible, etc.
Got it.
Yeah, I think there's a lot in like the question. I mean, you know, and I think there's a lot of people here that are actually like involved in this, whether it's like they're just as users every day or building tools for that, like, you know, Apollo, or like even Prisma and Hazura, like, you know, everyone who deals with like changes and schemas and how, you know, you deal with API changes. And, you know, at first, like, how do you actually there's the whole area of, let's think about the API at the first place, like where can we like just collaborate in a place on the schema and agree on the schema. And then once we have a schema, let's go implement that. And then, okay, so we have a schema and we have some services, and we have some services that consume that. Now we want to change that. So how do we offer changes? And then when we agree on the changes, how do we go on implementing them? And then once we implement them, how do we go on deploying them? And how do we do gradual rollouts? And how do we not break things? So there's like a whole chain of, I think, things to think about when we change. I don't know even how to call it, like remote sources. Like it's the same, and there's many tools that are already there, and there's many tools to be built. I think if we start from the first process, I don't know if we have today, maybe some other people know about a tool where you could just start collaborating, kind of like a Google Doc for GraphQL schemas. I don't know if anyone knows about something like that. I don't.
I think it's like a Google Doc. You just write.
Yeah, exactly.
And start typing out the GraphQL schema.
I mean, that's also cool to hear that there's nothing like that, because I think it will be really cool to build. I mean, and maybe not too hard. I mean, with Monaco editor now and things like that, I think we can actually create something really cool about it.
Yeah, I think so. Yeah, maybe sorry, go ahead.
No, just that's so. I think it will be really cool to start, and I think then once you have a GraphQL schema, there's so many existing tools, that you could now just you can fake responses immediately and start the work. You can generate types from it, from the client and the servers, of course. Once you have a server, there's all the crazy code generations that OneGraph is doing. Like, there's a lot of things that could be done. I don't know. I guess for me, I think maybe, yeah, like a place where people could collaborate on schemas. Just kind of like a Google Doc for GraphQL schemas, I think would be really cool. Yeah.
That makes sense. And I guess maybe two aspects of that build piece that I'm always curious about, to see if people are kind of if there's any interesting things that they've done internally or things they're doing are around one, which is this case of if there's anything interesting that they're doing around the kind of GraphQL API documentation, right? Whether it's kind of embedding that in the schema, whether it's making it a part of like the source code or the GraphQL engine code that's written, and pulling out the documentation automatically from that. But would love to hear kind of any specific things that people have done or tools that people have used or improved to work around that kind of API on the GraphQL API documentation side of things. And then, well, I had another question as well, but maybe we can start off with documentation. Any interesting thoughts there, folks?
We've given some thought to that in the context of Studio. We're trying to, I mean, one of the things that motivates me when I think about Studio is trying to think about like, what would be, like GitHub is a tool that brings Git to life, makes a collaboration hub for people to come and discuss. It makes it easy to find the state of your code, easy to see its history. And I think a lot about like, what would an equivalent to that be for GraphQL, and how people do that for the API, the state of the graph, things that are relevant to evolving the graph. So lately in Studio, we've been trying to build a lot of that into just like the free, like ubiquitous part of what we built in Studio. And we've built a lot of documentation related stuff in the last 6 months. I think there's actually some pretty cool stuff you can do. Like if there's a lot of GraphQL docs generators out there already, just based on introspection, but there's stuff that you can pull out. Like if you're building docs for GraphQL, you can kind of identify schema coordinates. I've talked with someone in the working group about schema coordinates, and you can like hyperlink those things around to other parts in your documentation and make things a lot more usable. If you're doing like federation related stuff, you can also browse your schema and see like which subgraphs do different parts of your schema come from, or theoretically like what are all the different subgraphs and the documentations for the different subgraphs, like who owns these subgraphs. Like there's a lot of stuff that you would want to see in the documentation around that. So we're trying to build a lot of that in Studio. Someone in the Zoom chat has also asked about Apollo Workbench and VS Code. So Uri, when you were talking about GraphQL schema drafting, we've prototyped a lot of that in Workbench, which is a VS Code extension that we put out there kind of recently. So you could come into Workbench and like, Workbench is very federation oriented. So it's about helping you make like schemas for a few different subgraphs, not just one. But you could come in, like draft some schema stuff. You could export, I think, like a Docker container with a mock server. And it's really there to help you kind of see what you're doing, separate the actual implementation, so you can kind of decide what you want to build. And then once you've decided what your spec is, then you can go execute it in your code.
For someone that doesn't know what the Studio is, do you mind kind of giving us an overview of that?
Yeah. Sorry, I should have done that at the beginning. So Apollo has Apollo Client and Apollo Server and Apollo Studio, and these are the three orbs that we build inside the company. And Studio is a SaaS app as opposed to the client and the server, which are frameworks in TypeScript. And so Studio, like, it is hosted, but it has a lot of free stuff. It also has some paid stuff, which is how Apollo makes money. But a lot of the free stuff is oriented around helping you get started seeing what's going on in your graph, helping you like share that with other people. So yeah, we take a lot of inspiration for the free parts from from GitHub. Like we want to help people collaborate on their evolution and everything, their graph evolution.
Yeah, maybe kind of related to that question, is the idea, Daniel, that you're seeing, is the collaboration workflow integrated with kind of like version control as well, or is it almost like a separate like activity? And I'm guessing like, I'm thinking maybe in my mind, like that maybe two approaches to kind of some of this documentation and collaboration stuff, right? One, it could be like an approach that is a little more like, say, the open API spec or the Swagger style of doing things, right? Mm-hmm. Which is that you like write down the documentation in version control, somebody updates that regularly as a part of their like process of writing code, or maybe even auto-generate portions of that, right? And then the other is kind of like a Postman or Insomnia type situation where it's a separate thing altogether. And you both have kind of their pros and cons, but what have you seen around kind of both of those approaches, and what are kind of the thoughts there?
Yeah, I mean, I think our dream is to be both and more along the latter side, where a lot of this is built into workflows in the cloud, which just we can store a lot more state for you. But right now it's very much the former. So we're trying to just really supercharge the types of things you can get if you do bake certain patterns into your schemas. So like if you're writing your schema and you write descriptions on fields using certain formats, or maybe you decorate things with certain directives in certain ways, we can start pulling that out of the schema that you've like checked into your code and showing that for you in an embellished way, just like as a first step forward. We were kind of thinking that starting with taking what you've checked in with your code and building on top of it would be a easier user experience, because most developers are working on the graph in their code. They're not like come in a studio to do things. Like that's just not their mindset. So it'd be nice to give them a place to control this where they're working already, but then to just start building things on top of it for later.
Got it. No, that makes sense. And Joey's nominated Ilya to talk about the open source doc generator stuff that you've been doing. So Ilya, would love to hear your thoughts.
Yeah, so we're actually using Apollo Studio, but one thing that wasn't working for us was the fact that the studio is the cloud provider. So you have to feed the schema over to the studio all the time, and with the enterprise environment and SSL certificate switches, it's a little tough to do in certain cases. Also, the one thing that wasn't working was that it's a good documentation kind of generator, cloud-based documentation generator, but it's not tweakable. So, for example, my graph heavily relies on directive on the server side to specify which queries and mutations are authenticated, require authentication, or require certain permissions. And because there's no way to tell Apollo Studio, like, hey, here's a directive. If a schema is marked with this directive, if a query is marked with this directive, please add a blob of text somewhere. So I just kind of threw together a static generator for the documentation. I called it GraphQL Info, and it's very much work in progress. But the goal there was to make it as modular as possible. So it consists of the core and a bunch of plugins. And anybody can create new plugins, can add their own plugins. So like for directives, for example, I have an internal plugin that will automatically like change the navigation to put in lock icons on the queries and mutations that are, require authentication and so on and so forth. Right now, there's, I think, 4 plugins that I created. One which automatically will read the queries and mutation schemas and generate sample client-side queries, including all the fragments and all the input variables for you. So you can basically just copy and paste it into, your runner of a choice and run it there. Eventually, it could be a built-in runner directly into the documentation if you wanted to. Nothing stopping it, from happening. But I just didn't really need it, so I didn't build one. There's a plugin for finding all the references for a given type. So when you have like, I don't know, an object that is being used inside a query, when you look at the documentation for an object, it'll list every single query, interface, union, etc. that is using that type specifically. There's a few more. The one that I didn't do, which I want to do, is ability to take an MD document and embed that directly into a documentation for a given query mutation type or anything else. So kind of textual overrides, I guess. But yeah, it's open source right now. It's very much a work in progress. There's not even a README file in any of them. Just haven't gotten around to it. And it isn't quite optimized yet. Like one of the examples that I ran into a problem with, GitHub schema is enormous. It's just gigantic. And until I changed my sample query creator to actually create fragments and input variables, Node would run out of memory trying to, build up the example queries for GitHub schema. They would be like 50 pages long because they're gritty. So once I changed it over to use fragments to generate fragments automatically, now it passes, but there's definitely room for improvement. But
that's awesome. If you have a link to the project, Ilya, would love to see that on the comments. But I guess like also if I understand correctly, the way that you imagine Ilya this being used is that there are developers who are working on different services that might be upstream sources into the GraphQL system or the GraphQL system itself, and they are maintaining kind of a documentation, a separate documentation asset, like a separate documentation project, like what you would do with things or Markdown or whatever. And that's kind of the life cycle of like the workflow, right? Where you're building out the GraphQL service, then you go update the documentation, and then that's published internally or externally as like a static website. Is that the rough workflow?
Not really, not right now. At least I'm not using it that way. It could be used that way, but the way I'm using it right now is I basically have a Git hook set up. So on merge to master, on post merge basically job, it'll go and regenerate all the documentation based on the schema itself. It uses comments inside the schema to generate, some descriptions and whatnot. But for the most part, it's just generating documentation based on the schema. Now, once I create the plugin for like textual overrides, as I said, like being able to grab MD files, for example, and render them out, you could potentially have another repository where you keep your documentation like MD files separately. But the process is automated. It just runs on post merge basically, and automatically updates the GitHub pages where I'm hosting the documentation.
That's very interesting. Anybody else would exchanging any notes on anything interesting that they're doing around their GraphQL API documentation, especially anybody anybody who has kind of like a developer facing API, meaning like either an API that's maintained by one team but maybe used by other teams, entirely different teams, or even a public facing API like Shopify or GitHub or something like that. Would love to hear. I'm going to pick on Sasha because Sasha's been silent for a while. Sasha, any interesting updates to the GraphQL development lifecycle at Twitter?
Nothing too exciting in terms of like documentation. It's the same as it was, and we don't have any outward facing documentation, at least for GraphQL. But it's all, as people may know, it's all generated. So we put it into our thrift and it goes through Strato. So it's kind of generated for us, but we add it so it shows up in the schema. I am curious about, maybe this is like changing the topic, but I'm curious about just like lifecycle development in general with the schema. I know that we've talked about like when is like a field or something in development versus in production, and like how do people deal with the kind of move from a development field to production, or if that's even a thing. I think we've talked about like people will version the whole schema. So I know we've been kind of like working on that a little bit and trying to figure out like what the best way to do that is to make sure that people can still develop, but then and like see it in production, but maybe it's not a production field. So yeah, I'm curious what other folks are doing with that.
I can speak a little bit to what we do at StockX. We've put a pretty hard stance on nullability of everything. So we force our clients to pick and choose if their response is valid or not. So in this case, they would pick and see like, hey, I either got this field back or I didn't. And then I can make the decision of what to do from there. It also kind of forces the backwards compatibility. So if that code ships early or late, it's still there and it can still work when we turn it on the server side, or if a backend service isn't ready yet, or it's not returning the correct amount of data, or it changed its response. We can just feed that through, and with the nullability, it'll either hide itself or show itself depending on that working or not.
Yeah, but that question is very interesting. Like kind of like a feature flag on the field or on the endpoint itself. What is the approach that you folks are doing, Sasha? Is it like a different endpoint altogether, like a /GraphQL or /beta/GraphQL or /dev/GraphQL? What is the?
Yeah, so it'll be like the same endpoint, but we use like annotations or directives to show like, oh, this is like a development field. What that usually means in practice is you can still access it like in production, but it'll, you'll see it as like a development field, or it'll sort of like, cause itself to act almost deprecated, like it won't show up in like the production schema. But what it does mean is we can, like one thing that's really important is also that like goes through privacy review. So a development field can't be a production field until it's like gone through all this stuff. But it sort of means that you can have, in cases where like maybe, we missed it in review or something, you can get a field that is being used in production that is a development field. And I think it's like maybe, people haven't figured out quite what they want to do with the field, or it's not getting all of like the, data it needs yet, or things like that. And at least so far, we haven't found a way that is like more ergonomic for folks when they're developing, because usually what we want is like, we want to maybe test something like in dog food or as an experiment. And it means that like, you kind of have to put the field in the schema, but then if you want to change it or like back out some stuff, you're like, actually, I want to change how this is modeled completely. You're kind of stuck a little bit, and you can, you know, pull fields out, but it messes with the, you know, GraphQL way of like, you know, you don't want to like rename a field or like completely change it, because now it is in production, and like the schema was generated with that. So clients might have that piece of it. So.
Have you ever tried marking it with like an experimental directive or something like that?
So that's basically what the development directive is supposed to be. But I don't know if it, maybe you're thinking of something else, but it hasn't really quite worked as well for us, but we implemented like our own development directive, so.
Just to follow up on that, just out of curiosity, are you guys exposing stuff without a client need before that, and thought of a client needing it in the future? Or what's the case of doing something in that? I'm just curious because we take a big stance of like, don't expose it until it's needed to kind of fight against that, putting it out and then pulling it back. So I was just curious when this comes up.
It's usually for like a new feature. So we'll like be making a new feature, and now clients are ready. So they've started like messing with it. And then it turns out on like the back end or something, it needs to change as they're like developing this feature. But one of the, like the whole part of the process is to develop this feature. A lot of the times the clients want to integrate it as soon as possible to get things rolling. But then like sometimes things will change on the back end. And now it's like, well, it's like not in production, but like it's kind of in the schema. So.
Yeah, it's been interesting. It's been interesting because we've seen a lot of people kind of asking for like, they want blue-green rollouts of their API, right? They want to have like a blue API and a green API, and it's been unclear how to reconcile that exactly with GraphQL, right? Like there's kind of pros and cons to whatever, like different possible approaches that you could take, right? Whether it's directives or whether it's having a different endpoint altogether, or you know, and you know, different ramifications that it has also depending on how that GraphQL API is being consumed. Because if it's being consumed by developers directly, like say a GitHub API, then maybe an entirely new endpoint is also totally okay. Like, you know, vnext/API, which is an experimental API, you can keep trying out new features. But if it's actually being integrated with a client in production, you can't really have different endpoints. It kind of will destroy all of your client-side setup that you have, right? So it's been it's an interesting topic. But yeah, and I think kind of on that similar update theme at places, I remember we were chatting last time, Joey, with a lot of interesting stuff happening at PayPal, the stuff that you were doing. Any interesting updates on just generally the API lifecycle and the GraphQL design that you guys are gradually settling on?
Yeah, definitely. We've made a lot of progress since the last time we talked. We're actually going to release this month, starting with some internal applications, so not public yet. But our API is intended to be used both by PayPal applications as well as public partners. And Sasha, this actually has a lot to do with what you're talking about. We have this problem where we have applications which traditionally are backed by BFFs, and then we also have like source of record teams, like data teams, and they serve different purposes. So obviously our public-facing API is going to be very data-driven. So the service teams will just produce a schema of the capabilities at PayPal, and you know, we don't know who's using them, so we can't really take a use case-driven design there. However, we do like use case-driven design for backing our products because they know exactly what they want, and we don't want them to have to orchestrate too much on top of, you know, a very generic schema. So we're faced with this choice: do we let these BFFs live on the graph, and what does that look like? So we are going to let them live on the graph, but they're going to get a namespace and they're going to be internal. So you can't see them. But the cool part about putting them on the graph, and we're using Apollo Federation here, is that these BFF subgraphs, they just get like a UI namespace. So you'll see UI something or UI underscore for the type namespace. But within that, like it doesn't show up publicly. In fact, we use an auth directive to scope it to the project that it's intended for, so that these teams now gain autonomy and agility over having this space where they can just move quickly, deprecate whenever they want, not worry about other people using them. So, you know, it's their BFF for their project. We're finding that it'll be beneficial for us to let me back up a little bit. it was a really daunting task to like decide on how to create the unified schema at PayPal. It's massive. There's a lot of entities to represent. And as we include other, adjacencies like Braintree and I don't know, Venmo in the future or something like that, it's very difficult to say, okay, well, you call them transactions, we call them, financial instruments versus bank accounts. And there's this big data modeling exercise that has to happen. And it's very, very daunting. And it actually will hinder your progress a lot when you think about it too much. So we decided to not think about it too much and say, hey, let's let the BFFs do their thing. And we'll just like watch their subgraphs. And as things pop up that are common, we'll pull them out and give them to the right teams. Because also BFF teams, they don't want to serve data to everybody. That's not their job. They really want to be concerned with their client, and that's it. So if we find out that like, oh, these 5 BFFs are making a user type because we don't have user on the graph yet for some reason, then we'll find it and we'll say, hey, identity is supposed to own this. They're a service team. They'll think about it the right way. They'll look at all of the use cases from the BFFs, and they'll design like a more informed official user type that will then get used. And people can deprecate out their user type and say, okay, looks like they added it to the main graph. We can get it out of our BFF, and these BFFs become thin over time because they don't need to do as much as the graph grows. So we're using this as a tool to grow our graph. We just watch the BFFs, build the graph, and don't worry about it too much.
Got it. That's interesting. One of the questions I've always had with these kinds of things where you're unifying a lot of different types of entities for lots of different use cases, right? Is that as a developer, if I hit that GraphQL endpoint and I get that schema, right? Do I see the schema that shows me like, the BFF1 namespace, BFF2 graph, BFF3 graph, and then the other like the kind of more upstream specific, data oriented graphs, right? Do I see all of that in one place, or because it might be a little bit overwhelming, right? And especially, and doesn't help really, just an extra friction step where I would rather just see my GraphQL schema, right? That I am supposed to be scoped into at this point, whether it's a different endpoint or whatever it is. But how are you folks thinking about that? Or is that even a problem?
Yeah, so we have like application contexts and scopes. So basically we can say, like, no matter what, you can't introspect our API unless you have some sort of credentials. Those credentials will inform us as to what we show you. So if you don't have the right scope, then you're not going to see BFFs from other teams. That's the intention. But as a graph admin team, we get to look at the whole schema and say, okay, looks like you guys are all doing this. Let's prioritize this, get it out of all the BFFs, and that we can go that way. So you only see what you're meant to see, basically.
Got it. So kind of like scope-based schemas or role-based schemas or whatever, right? Like it's scoped into the right. Okay, got it. That makes sense. That's very interesting.
I have a question for you on that, Joey. I feel like we've been, so I work at GitHub. We definitely have this issue with the GraphQL schema when developing for enterprises. So a schema for an enterprise is different than the production schema. And the introspection is definitely the way to kind of go about this. But on the scale that we have, like such an incredibly large API, we would have to make different clients for each version of enterprise. And so the introspection doesn't really scale, from our mobile apps hitting. We'd have to have a different mobile app for each enterprise. And so, yeah, I'm curious if anyone else has had this issue with enterprise type GraphQL APIs, how they've been handling that. Because, yeah, we have to essentially version our GraphQL queries to know kind of what version of the schema they're going to be hitting inside of the client instead of handling that, somewhere else.
Got it. So sorry, Naomi, just to clarify, I'm not sure I understood when you say the difference between the enterprise GraphQL API on GitHub and the normal GitHub GraphQL API. What's the difference? Is it that like enterprise means that there is a unique installation for that particular enterprise and they have a GraphQL endpoint at a particular checkpoint, whereas the normal GitHub service is like a cloud GraphQL API that's like it's a SaaS thing that's just continuously getting upgraded over time, right? Is that the difference? Or
Yeah, correct. Yeah. So like an enterprise instance gets cut at a specific instance, but then the regular GitHub is continuing to add more endpoints and change them and add new fields and arguments and stuff.
Yeah, I don't know if we're still at the beginning of our journey, so we have lots of problems to face, but we are not relying on introspection. I'm not sure this is related, but we're not relying on introspection solely to like generate SDKs. We're actually working with Apollo pretty closely to essentially, they have this concept of variance, and this actually works really well into our workflow as well. But we can decorate, this is the intention, we'll be able to decorate our API or our schema with different, auth policy directives and like visibility directives, and a whole different graph will be generated for a particular client. And we have, for internal consumers, we have a little bit of a multiplexing. So we just say, oh, hey, you're this person. So you're literally going to get a different Apollo server than this person. So there might be like, I don't know, 20 different Apollo servers on one API. But based on your credentials, you'll see a certain graph. So that you won't be able to access any other fields at all.
So the client would break if it was trying to access a field that wasn't on that graph.
Yeah, even if you don't see it on introspection, it doesn't exist basically.
Yeah, I think we've faced similar kind of interesting things because we have a lot of kind of self-hosted installations that are getting updated, especially in enterprise environments, and that have a very peculiar kind of update frequency, which is different for everybody else. But what I was curious about, Naomi, was that what is the difference between having GraphQL and not having GraphQL in this case? Wouldn't this problem also exist if you weren't using GraphQL? And isn't it just like a normal software versus SaaS kind of problem, if you know what I mean? What are kind of the unique challenges there that are GraphQL specific that you're facing?
Yeah, I guess GraphQL will kind of explode if you pass something that isn't in the schema if you don't expect it, Right. So I think that's more of the issue, is that we can't softly fail if we're requesting a query that doesn't exist on a schema. And so I think that's where the issue is making sure as the schemas change, how do we catch things, before they go out, to know, which I think is this introspection part of it, is you need to figure that out, if that makes sense.
Yeah, that does. That makes sense. I think something related that we've been doing is kind of like one part of it is like obviously the deep coupling to the introspection itself. So if you see something on introspection, like Joey said, you can run it, and if you don't see something on introspection, you can't. But the introspection is like a very exact source of truth about what's possible and what's not possible. Any other runtime errors are legitimate runtime errors. Like could be like an internal error, or could be some other kind of error, right? So that's a legitimate error, but it's not a API mismatch kind of problem. I think one other thing that's helped in the so what we've hooked into with the GraphQL engine, with the GraphQL service itself, is that part of the log capture of the monitoring capture, what it is doing is capturing all of the different shapes of queries that are ever being seen, and then just creating kind of a unique suite of that, and then just running that to get like a schema validation and maybe even a data validation. If you have a good staging, if you have good staging systems, then you can even do some element of data validation to see that. And that gives folks a little more confidence in shipping or making changes, especially in these kind of software style environments, right? Where one test doesn't fit it. Everybody needs to run their own test to make sure that things work well. So that's something that we've been experimenting with, which is going okay.
Out of curiosity, for the GitHub schema, is it always monotonically increasing for all of these enterprise clients, or do they sometimes have their own fork and their own custom schemas?
Technically, they could have their own fork and custom schema, but we keep them I think we do a very good job of not forking.
It seems like almost like you could maybe take a page out of the Relay book and maybe annotate even at the fragment or the query level for your specific, mobile client in this case, saying that, I want to analyze this and go ahead and make the introspection query. And if this component is not satisfied by that, then basically this feature will no longer be available inside of the app. So basically push it a little bit up into the client where the client can say, I want to opt into adding this feature if the server is able to support it at this point.
That's what we do right now. Yeah, it's just that, as we support more enterprise versions and like the code gets larger, the scale of that kind of work just adds extra complexity to the client.
No, that makes sense. Cool. So I think if anybody else has anything interesting that they'd like to share on the lifecycle front, please do pitch in. But otherwise, we can move to the next topic. So I'm going to do like 10 seconds of silence to wait. I'm kidding. All right, so we'll move on to the next thing. Also, please do feel free to keep pinging me on chat and asking me or letting me know if you have things that you'd like to talk about or any questions that you might have, and I can always help kind of prompt you in. But otherwise, kind of moving on to the next section on of our discussion today. Ash, would you like to just introduce kind of the topic on observability and security and other challenges around GraphQL, because you suggested it. So would love for you to kind of just intro that in.
Oh, all right, cool. Well, I'm not nervous, totally diving into this. But yeah, as most of us have probably encountered, this is kind of a bit difficult. We're understanding probably at the early stage how GraphQL is doing everything that it's doing in production. So I did do a talk on talking about how we can use OpenTelemetry, which is a spec by the Cloud Native Computing Foundation, and there's a few other companies out there talk on how they've applied it to essentially tackle the problem of really observing their systems in production. Now, yeah, that's kind of one thing I kind of wanted to, I guess, like open the floor and see how everyone else is tackling that problem. Are you also leveraging OpenTelemetry? Now, there is one thing that I know during the research that I was doing for my talk that I encountered, which was the instrumentation specifically for GraphQL. I had some challenges getting that running, which kind of like allowed me to pivot into introducing the little plugin and how to apply OpenTelemetry to like a vanilla GraphQL JS or just any vanilla GraphQL project. But that is something that I don't know if anyone else is experimenting or diving into, seeing how we can they're really instrumenting their GraphQL servers. Yeah, we can go for there.
Naomi, would you like to chat a little bit about what you folks are doing at GitHub?
What was the exact question again?
So
yeah,
kind of like, sorry, go ahead, Ash.
Yeah, no, so I guess maybe can you like dive into or maybe share how GitHub or your team tackles observing systems, your GraphQL systems in prod?
Observing how we do, yeah. So it looks like Kyle had something he'd like to say on this as well, but we use a lot of, actually, we have about, we're running to do a technical blog series on a lot of our GraphQL stuff. And, I'm taking a lot of things from this conversation of what we can talk about and get the right people at GitHub to talk about these things. But we actually use a lot of, like we use Splunk and yeah, to figure out how long, who's hitting. I mean, we have a huge GraphQL API, right? So we have a lot of consumers, and so we have 10 seconds of silence. Sorry, I'm reading the comments. Yeah, I guess maybe Kyle can talk so he can spark kind of what I should say about this.
Sure. Give you some time to collect your thoughts a little bit. So Ash, we run Apollo, like you guys talked at the Apollo server about. We use the lifecycle hooks. So right before we actually respond, we actually use Datadog to parse out that response, see what's in there, see if we have errors, and then print it out. And then log that out and say, hey, we have this many requests coming in, this many requests have errors going back. And sometimes we look in a little bit more, but for the most part, we don't. But we also run Apollo federations, and we're running about 20 some in production right now. We do that same thing at our federation level as well, which is pretty cool. So we can tell you not only do we have an error, but where did that error come from, what federation, and then even trace that down farther. I know you did a lot of awesome custom stuff to make your stuff work together. Datadog actually does a lot of that stuff out of the box for us, which is really nice. It'll even cut the federation queries from the gateway to the actual implementing service, which is really, really nice. But yeah, we do a lot of stuff like that with the lifecycle hooks.
I remember about maybe it was about a year ago, but Ben had done some very interesting work in doing some kind of performance debugging and analysis. And I remember seeing that tweet and analysis blow up. But Ben, any interesting insights to share from there, or any recent work that you've been doing around just kind of instrumenting and observing what's happening and fixing stuff?
That's what I was going to say. I'm not sure if we were talking about tracing here at all, because I do have some opinions on tracing and like the performance of how long your resolvers take. So as far as like counting errors and stuff, I just use like the Apollo format error stuff, and that works great. But as far as getting the performance, or not the performance, but just like I want to see how long each one of my resolvers is taking in the schema, and like try to pinpoint where the performance problems are. There's like some existing stuff like Apollo tracing and stuff. But what I found is like, especially if you have like a good chunk of data, resolving and timing each of those individual fields like kills performance, and also is not that useful. Like I don't really need to know how long like each individual field like resolves. It's usually your data sources that are going to be the bottleneck. So instead, like I found like tracing, how long did it take from Postgres to get the data, or like each one of your data sources. So I stopped tracing the GraphQL schema, like just put no tracing whatsoever in that and put it all in the data sources. So that's kind of what I did, because tracing in the schema wasn't that helpful for me. Yeah.
That's
interesting.
Yeah, especially as
it's more like. Go ahead.
No, because that's a very good point. Also, one thing that I kind of encountered and was a question was like, well, especially if you're using your GraphQL server as the entire server and performing most of your operations there, that seems like a very reasonable conclusion. But as that GraphQL server talks to some of your other microservices and being able to, and you might have additional instrumentation to follow the request flow through your other microservices, kind of like saying, oh, okay, well, tracing was, of course, the de facto answer to come through, but definitely other approaches to go about it was definitely something that I'm curious to see if anyone has kind of with that same opinion of, well, tracing seems to be overrated. How do you follow through your distributed infrastructure to see where performance bottlenecks may lie?
Yeah, I feel like I think with in line with what Ben was saying as well, I feel like usually just having some amount of like network tracing between the various components that are interacting is good enough, right? Where you're just like you just trace everything that goes in and out for everything, right? And then just view the whole aggregate on Datadog or whatever thing supports OpenTelemetry or Jaeger or whatever, right? And that becomes that's good enough, right? Because there's a bunch of problems there that you can fix. So that's that.
If you can also do like the higher level, it's better. Like if you can get like the top level resolvers, but it can get into like, I don't need to see how the 10 username fields resolve, and because they're all going to be resolving the same way too. So you're almost getting duplicate like info. You just really need like it once. Yeah. So that's the other thing. If you can do it the more high level you can of the resolvers, the better.
Yep. No, that makes a lot of sense.
This isn't an option for everyone, but again, persisted queries are really nice here, because then you kind of see the performance as a like granular unit. Like this is the unit I care about. Was this specific query slow? And like that's enough to start reasoning about the problem.
Also,
sorry. Go ahead.
There's another, this ties into also like complexity limiting. If you're able to measure your fields or each field's performance, and you have a public API and you don't have the opportunity to understand what they're going to ask for, you can you can do depth limiting, but really what you want to know is like how complex are these things, because you might have one field that's just going to nuke everything, and if they do that 6 times, it's under your depth limit, but it's really, really bad. So getting this tracing information for on a field level, it can be valuable for that as well. And I know that Watson's not here from Apollo, but he's working on some really cool stuff that gives you knobs and dials so that you can look at these fields and say, oh, I'm going to turn this thing up. The value of this is too high, and it will basically prohibit certain combinations of queries.
Yeah, no, that makes sense. I think when it kind of comes to these, public API denial of service type things where you want to have some kind of complexity cost to decide what to do with the API, there's a few interesting approaches, and I'm sure Naomi and GitHub will have a few interesting things there because they have a GitHub API, like a public API that they have to prevent. But one of the things that I've seen often, like that I think can be a fairly simple thing to understand is implement like a connection timeout, but have it like deeply integrated with the GraphQL engine or the service that's processing it. What I mean is, let's say, for example, there's a time limit that everybody gets to stay, that everybody gets for processing that query, right? The only thing that's important is having some kind of interrupt or async mechanism in the service that can say that, hey, this has gone on for like 300 milliseconds. We're just going to suspend execution, right? So you just want to suspend any execution and terminate that, right? And I feel like that's something that I think databases have done for a while, right? Like databases have had this problem forever, ever since databases first came along, and they have like an interrupt mechanism that's internally built in to say, as a database processes like a large query, at every step it's like going through a interrupt check to see has it crossed any thresholds, and if it's crossed a threshold that's been configured that's violated, it just pauses execution, right? So having like a deeply built connection timeout thing, and then maybe even measuring that so that you have a quota, right? Like you have a quota of execution time that you get, and then just maintaining a quota for people. That I think maybe that's kind of a slightly more technically complicated approach, but that's simpler for a public consumer, because I mean, if you're going to give me the depth and then you're going to give me depth in the GraphQL schema, but then have a depth limit on it, I'm confused. Why did you give me that depth in the GraphQL schema, right? Or why did you allow me and show me a schema that I can query, but then at runtime suddenly say I can't query it? So that it's very interesting for public APIs, I think. But yeah, any thoughts there?
You also want to be able to set expectations. That model is actually fantastic, but I would like to be able to tell our consumers that query is probably not going to work. We have historical data in all of these fields, and we know that this adds up to past your quota. So I would say implementing both is good, but being able to inform them, this is not what you want to do, it's too expensive, would be nice. And automatically, right? We measure all of our tracing anyways, so why don't we use that to influence our limits?
So I guess at Loblaw Digital, where I work, we have, in terms of handling the performance aspect of it, we're using a tool called K6 that essentially gives us like a lot more metrics in terms of what specific API response time is like, because having, I guess, shoppers being such a huge e-commerce website here in Canada, we have a lot of like requests, and I guess like even concurrent requests from different devices and whatnot. So I think like our approach has been kind of like looking at as we build our resolvers and GraphQL type schema and whatnot, and when before I guess we deploy it, and before our web app or web client or mobile client starts using it overall as well, we integrate this as part of it, wherein like the core user flows for what our e-commerce application would be, run these bunch of K6 tests just to make sure like it essentially like it's the response time and everything is like as per what we like. And eventually the plan is to do like more of a load testing scenario, because there's only like so many checkouts you can do and handle essentially as well, so the user get a much better user experience. So like that's one of the approaches that we are tackling as well, which is working out pretty well.
Oh, thank you. Yeah. Well, I guess that was the first piece. Everybody, thanks so much for sharing, and that was very enlightening. Very good perspectives. Maybe another piece is pretty much authorization and how we apply that to our GraphQL schemas, whether you do it in your implementation level or within your schema level. There's quite a few interesting approaches that are being taken, but I think it seems like that we're more and more converging onto a very common pattern. So I wanted to see how does everyone. Sorry, but Joe, I remember you mentioned something. I guess apply auth directives with authentication policies, and there are various ways of doing auth directives. So I don't know if you would mind talking a little bit more about that.
We just do a really simple auth policy directive. It's got, it's got the scopes, and it has like different logged in states. So if there's a user, we can say this is, you're okay to access this if you're remembered or logged in. But really simple stuff. And the scopes is the big power of this. It lets us control access to different clients.
Sounds good. So scopes is definitely one way, and there's so many different ways to apply authorization roles to an application. I don't know if anyone has any different implementation that doesn't really rely on like auth scopes. Maybe if tackling from different types of contexts, whether it's from a user specific or a resource that they're requesting upon, or some other types of roles, and kind of like combining those.
Yeah, we've been doing a lot of work on that front. We've taken the approach of not having the authorization kind of policy engine be at the GraphQL level, because I think having the auth policy at the GraphQL level is going to provide the kind of authorization and security that you could potentially get out of an API gateway, basically, right? Which is more around kind of like visibility type security and like visibility based denial, but you're not really getting kind of entity level authorization, right? Which is that I can access this document if document.collaborators has me, or document is public equal to true, or I am admin, or whatever, right? Like there's a whole bunch of conditions that make it possible to view a particular resource. And so we've taken an approach kind of inspired by a row level security that was, I think, introduced in Oracle Sybase DB2 type databases, and then kind of got ported over to modern databases as well occasionally, which is this idea of basically being able to specify policies at a model level. And at a particular model, you specify kind of a policy, and then you can label or tag that policy, right? So you can say this is a policy for a scope called admin. This is a policy for a scope called manager. There's a policy for a scope called whatever. And that policy is composed of two things. That policy is composed of field level visibility at the model, but then that policy also contains information about that particular entity being accessible or not, right? So it's like saying that if I have a user model, the user model, if I'm a logged in user, right, as the scope, then I get to see ID, username, email. But then if I'm not logged in, then I get to see ID and name, right? And there's different field level visibility and different like entity level visibility. And then you can combine scopes together as well. So when you can combine these scopes, these policies have to kind of be merged together. So I think it's kind of, my gut feeling is that a lot of depending on the kind of use case, of course, right? But for like heavily transactional applications, I would assume that the policy engine is closer to the implementation of the resolver logic and embedded there, because it also has to be closely coupled with data fetch. Because if authorization and data fetch are two separate, like authorization is happening in a completely different context to the data fetch, then everything will be just too slow, right? Like you can't go and fetch all possible users from the upstream source and then apply a filter and say, oh, you only get to see your profile, right? So it has to be kind of coupled in the implementation of fetching the user, that you're fetching only that user that this person has access to, right? Or that profile that this person has access to. And you're not kind of re-implementing what something like a database would do at the GraphQL level, right? So that's kind of like what we've been seeing. But I think like even if you're building your own system, there's probably some kind of auth library, internal library that you're building that is helping out with the implementation, that is coupled with the data fetching from the upstream sources that probably helps. But yeah, would love to hear what other folks are doing.
I mean, I think
Yeah,
it sounds like what y'all are doing at Hasura is it's kind of similar maybe to what we were doing when I was at AWS, and I'm not there anymore, but we had, we have AppSync, which is kind of a GraphQL service. And there's kind of like two ways to implement authorization rules. One is if you're using something like Amplify, which is, I would say would be kind of similar to Hasura, where you're kind of modeling your authorization rules maybe at the schema level. And you kind of have these directives where you have like an auth directive, and you can combine things like group permissions at the field level, at the type level. You can combine these things, and you're kind of like, modeling this, these authorization scenarios at the schema level. And then by default, though, if the user is authorized, we also pass in, the user metadata via the access token into the context. And then at the resolver level, you can kind of do your fine-grained access control, or you can do your authorization and all that stuff. And that seemed pretty powerful. But I mean, I'm very curious around building out like these types of systems yourself, and kind of how people are doing them, because I really haven't had a ton of experience building out these things from scratch. While we did work with, I've been working with AppSync for a little over 3 years. We have we had massive customers, because I don't work there anymore. Ticketmaster and all these big companies and stuff that were kind of like hitting this and scaling it at early times. And I was kind of very understood how we did it, but I don't kind of understand how like I would go and run and build out my own server from scratch and implement all of this stuff and best practices around it.
So I do a similar thing where I used to start it at like the schema level, but I found that there's a lot of duplicate logic, because I would fetch the same data in multiple places around the schema. So then now I'm putting the same auth logic in multiple, and it was just bad. And so I just watched a Facebook talk and copy pasted their method, and they do a similar thing where you just have a data layer, and your data layer is like where you put all your business logic of like, if you're fetching this data, you put the authorization logic there, and it's based on what the data you're fetching. And then you just, in your resolvers, you use that, and then you're good.
That's kind of what I've been leaning towards, honestly, the last 6 months to a year, building out some of my APIs using CDK, where you kind of I've just opted to just write all of my business logic from scratch and kind of implement maybe a layer like that, and you have a lot more control and all that stuff for sure.
Yeah, that's actually so that I think it's kind of at the model level or at the schema level, right? And so we also do we've also seen success only at the model level. I don't think at the schema level you can get kind of like some kinds of things are just not feasible to model from like a performance point of view, not necessarily even a flexibility point of view, right? It doesn't make sense. Just exactly like Ben said, right? So the model level, I think, is what kind of ends up making the most sense.
The way I was kind of like, I was gonna say the way I would kind of look at it though is like, if you're a beginner to all this stuff and you don't understand how this stuff is working, having like a really easy to use directive or something just to kind of get you up and running actually is super helpful for onboarding and lowering the barrier to entry to like new developers. And then kind of like once you get past that and you start having these actual like production scale issues and things like that, then you can kind of go into that maybe.
I wonder if there isn't a combination of the two that ends up working well. So as from a GraphQL tooling point of view, it's very nice to have the declarative, schema level, right? Or scopes with auth or whatnot. The idea being that you can propagate forward the requirements to the user really, really quickly, right? Before they even run this, you can tell them, hey, you're going to have these auths in order to access this block. And oftentimes what happens is whenever you're first coming to an API, you go and you find your API credentials and you run it, and it turns out that actually you filled out something wrong, and you fix that. And like 3 or 4 iterations into this, it turns out you don't even have permissions to access this resource in the first place. And you would have known that had it, and you wouldn't have spent the last 20 minutes trying to figure that out. So I wonder if, with this kind of imperative escape hatch, which is what you're talking about here, largely, I think maybe Tamai is more declarative. It's really hard to propagate that into the schema, so where tooling can kind of generically read that and warn the user ahead of time. So in some ways, it might be nice to at least just annotate the schema a bit and say that, look, there are some guards for this field, just as just some warning sign kind of thing. And I wonder if not, or if you couldn't, do an at auth and then the name of the rule that you're using to actually declare this, right? And that would be enough to then build sufficiently good tooling for a new user onboarding experience.
And I think in most kind of complicated production environments, especially that what we've seen is like the policy engine is very complicated and it needs to be like almost its own thing, right? So even if you're building it yourself, within your code, you're probably trying to isolate it into some kind of module that makes it a little more declarative and composable, just while you are reusing the same rules or the same style of authorization in your code, right? So I think that I think whether it's imperative or declarative, I obviously prefer declarative, but that policy engine is a thing that needs to be there. And then having some sweet spot in the middle or having a little bit of both would be nice, but yeah, maybe a little bit confusing. I would love to hear what other folks have been doing when it comes to authorization, if there's anything specific to GraphQL that they've been doing, or it's just delegated to the upstream sources.
Yeah, so I'll just add that that's one thing that we've sort of been struggling with a little bit, because not necessarily with authorization specifically, but it was more in the terms of visibility. So we started to bubble up a little bit into the schema. Specifically, we're trying to get to that balance of saying, hey, here's a warning flag at these field levels, where at least we're able to, one, just use CodeGen not CodeGen, but yeah, essentially CodeGen to generate other helpers or tools that help inform our UI as to what to even display in the first place. But yeah, this is something that's curious. But yeah, it's we're still figuring out to see just how well it'll work. But so far it's been it's looking pretty optimistic.
I'd like to ask a question just so we don't get too far, and I'd like to leverage you guys' knowledge here. But you guys were mentioning that there's a performance hit at doing it at the schema level. What we're doing is at our gateway, we're authenticating and we generate like a security context. And this is all the information about the user, what they can do. And we do that one time. And so I think it's not a big deal to check it at every field. Maybe I'm wrong. I'm going to put myself out there. What were you guys talking about performance hits?
So one of the things that I was mentioning was that basically the thing is that the rule engine for determining the access to entity, not the visibility of the field. But let's say, for example, like I'm using the PayPal API, I'm trying to access my profile, my account, right? So somewhere, even so the schema, whatever the schema is, right? Ultimately, my context has to be mapped to a piece of data, and then certain operations need to be done against the data and my security context. And they need to be kind of compared, matched, whatever, right? Like things need to happen there. And then I get access to that account, right? So if I try to make a request for like /account/me or /account/ID, right? Or a list of accounts, right? A list of transactions. Then when I, for example, make a request for a list of transactions, it has to be, there is a policy that has to be computed. Right, the claim and scope extraction is one part of it, but the claim and scope extraction has to be mixed into this, right? So that is one. And I think what Ben was talking about, which is also a particularly like insidious thing, is that the same policy, this policy of determining whether you can access a particular profile or account, you'll have to duplicate it in your schema. Maybe if you have different ways of fetching that data. So if you have a top level fetch profile, fetch account, and then maybe you have somewhere else, you have a nested field or type that uses the same account type, you're repeating the policy for those two things, right? Which you don't want to do. or you're computing them again, right? You might be computing them twice.
So these are like things that you can't know until you check against the data, the specific data they're trying to access. I gotcha. So I'm asking these questions for a good reason, because we just haven't gotten that far yet. So it'd be nice to know what we're going to bump into before we make decisions and propagate them throughout the company.
I'll add also, like, I think you can get rid of some of those problems when you like start introducing things like data loader and whatnot, and you can start caching some of the like permissions and stuff. But as far as like when I was mentioning duplicate logic, it was more from the point of me annotating my schema in all these different places when I know at my data model level where it's going to be. But of course, if you want to hide or show fields, you're going to have to annotate the schema. Like, absolutely. But as far as like you want to show all these fields and have different permissions on them, that's where I like sticking in the data model level. And it's not a performance thing for me. It's more of I don't want to stick the logic for how to fetch a user in these 5 places. I want the auth logic to sit right where I'm fetching the user, basically.
It sounds like the requirement here is a clean data abstraction layer.
Yep.
Because if you don't have that, how are you possibly going to, as a pattern?
Exactly. And then I think the challenges there are interesting, because like if people have very different ways of expressing those policies, right? Like you might have like a ACL system that is embedded in like an Active Directory or whatever, right? Or you might have like a policy engine like OPA that has these declarative policies specified that is computed by an external source, or it might be in your app server code, like it might be like in your Rails code, right? It might be like a module that's doing these checks and computations, right? And so there's lots of different ways of doing that, and then coupling that to the data fetch piece is important. Yeah.
Sounds like we are definitely missing that. Hey, let's make a consistent data fetching layer. And part of the reason is because, we acquire companies, some of the data lives there, some of the data lives there. We're kind of using GraphQL as a way to be that abstraction layer, but it sounds like there's another layer for performance that you might want to inject so that GraphQL is not that.
Yeah, exactly. Right. It depends on that use case. I think in your use case, it sounds like it's like an aggregator of different services. So that means that the policies are anyway not going to be known by the aggregator. The policy information is with the domain folks, right? The policy information is not going to be with the GraphQL service thing, right? It's going to be with the domain folks. So the domain people should use whatever policy system they want to use, and then it's up to them, right? Whatever that implementation is internally. So maybe it's not even a thing that you have to worry about.
Yeah, I'll just add, like, we have the performance and we have the tooling and like whatever, how you like manage roles and things like that. But I think in philosophy, even like it's not only on small apps, but actually when you scale and you have like tons of different services and you have tons of different teams, I think there's maybe some, when like we see in large companies, they introduce GraphQL, like a big manager comes in and say, they want to oversight everything and put like the right annotations on the one global schema. But in reality, there's a reason why, we made those like services. Like the authentication is the authorization, is part of the business logic. So the people that write the service knows best who should access it and who should not. So once you put it in the schema, it's very hard to scale. Suddenly there's like a central entity that needs to know all the different use cases and all the different things around the data and decide who should be able to do what. And that usually leads to everything becoming very slow in terms of organization wise, like not necessarily, even technical.
Yeah, that makes sense. Any other interesting things that people have been doing around authorization or lessons learned that folks would like to share?
I have a question for Ben Awad. Is Doghouse built with GraphQL? Doghouse?
So it is not. I'm using Elixir for the backend. So I do not have enough Elixir knowledge to like do a custom GraphQL setup because we're using WebSockets for absolutely everything. We may transition later though. Yeah.
Nice.
Absinthe is hot, man. It's good stuff.
Yes. Do you know if you can use it over WebSockets like by default, or does I have to do a custom layer?
I think you should be able to. Yeah, the subscriptions, I believe, just plug in.
Well, so it's like I do all my data fetching through WebSockets, like my queries, my mutations. Okay.
I think it should be fine.
I think the subscription, like the depending on the subscription protocol that you're using, you can even send the queries, mutations, and
Yeah, we do
GraphQL
that with
subscriptions over the
OneGraph.
same.
It's an alternative way for OneGraph as well, where you can just send everything over WebSockets.
Yeah. All right. Awesome. Yeah. So no, I think that's that was on the authorization side. I think those kinds of different concerns and things make a lot of sense. But the rough summary that emerges is right. If it's like a authorization has like many different things to it, right? Like there's a visibility aspect, there's a domain level policy aspect, and then there's also this aspect of where different pieces of that logic can go, depending again on how GraphQL is being used in that particular context. So I think that all of that makes a lot of sense. Next, we were going to talk about type safety and GraphQL. Ryan, would you like to kick things off with maybe just a quick intro to the topic and the kinds of things you'd like to discuss?
Sure, yeah. So TypeScript and type safety, really a topic that I'm curious about more and more these days. And so I work at Prisma, where TypeScript is a big deal for us because our product, or one of our products essentially right now, is a type safe database access client. So you create your schema for your database, and you can use like any kind of, well, not any relational database, but most of the popular ones. And you generate some code and you get like all the types for your database access. So you can essentially write your database queries just by, hitting dot and enter on your keyboard, that sort of thing. So type safety is, I think, super cool. What I really like about mixing type safety in other aspects of the stack, as well as the database access, is if you go to like change something at your database and you have type safety applied across your whole stack, you can start to trace back where you need to make changes elsewhere in your application. So if you've got type safety applied on your back end and your front end as well, and then you've got that type safety at your database, I think that's a really cool mix because it gives you a lot more confidence before you push out those changes. And so there's a bunch of tooling that is out there for help generating types from like a GraphQL schema, having a code first GraphQL schema approach, like we take part in with our contributions to the Nexus schema library, this sort of thing. And so what I was hoping to chat about with the group is like, what is the state of type safety around GraphQL? So GraphQL as like an API layer gives us a certain amount of type safety in terms of just like payload validation, for example, that sort of thing. But it also opens up the possibility to apply type safety in other parts of the stack. So, the stuff that I know about type safety wise would be like Nexus schema. That's the library that Prisma helps support. It's like a code first type safe way to make a GraphQL API. GraphQL code generator, generating types for you that you can apply across your application. So I guess I'm curious what people might be doing type safety wise. Are you using TypeScript around GraphQL? Are you generating types from your GraphQL schema? And what other kinds of tools exist right now to get the job done?
I'm going to be bouncing in about 15 minutes, but I kind of wanted to speak to a couple of cool things maybe in this space. Well, I guess one, at AWS, we were just doing some GraphQL code gen for the client. I think like a lot of people are doing, but at my new role, like I'm working in kind of like the crypto/blockchain space for a company called the Graph Protocol, and it's kind of like a blockchain querying like a layer. It's kind of like a database indexing layer on top of blockchain data. But I think the cool thing is that we're basically like doing this thing where you kind of like declare almost like infrastructure as code in something called a subgraph, and you define your GraphQL schema location, and you define what's known as an ABI, which is kind of like an application binary interface, which is something that's generated from smart contract code like Solidity. And basically using the GraphQL schema combined with your ABIs, you can basically generate a subgraph which allows you to kind of deploy to a hosted service or to like a decentralized service. And it kind of maps through every single piece of data on the blockchain and like creates data and stores it in the database and makes it accessible via a GraphQL API. There's a lot more to go into it, but it's pretty interesting stuff. And I'm still kind of learning it, honestly, but it's pretty fun and a completely new application of GraphQL, I think.
Nice. That's really cool.
I'd love to hear around kind of some of those type safety aspects from folks that also where JSON is not maybe the JSON is not like the lingua franca of the ecosystem that you're in, like for basically non-JavaScript or non-TypeScript ecosystems, for clients like Java iOS or backends written in non-JavaScript, like have people faced problems in some of those type conversions where when you say int, it could be int 32, int 64, int 128. Right? It could be big int, it could be small. There's like 1 million different kinds of ints, right? And there is a contract that needs to be a little more specific, perhaps, because JSON is being used as the transport format, but like the parsers need to be a little more aware of the way that they're parsing things. And Rob Zoo done an incredible talk a while back with some of these challenges around type safety. Have folks run into anything there, and any interesting kind of patterns that have emerged around how you've dealt with that? So basically JSON for life then. That's cool. Good to know.
Yeah, I'd be interested, to hear some more code generation stuff in general, like applications of code gen.
Yeah, for sure.
I can talk about one of the things we do here at GraphCMS. So we allow users to manage their schema through a UI, but also they can use an SDK. And where we use code generation is we use code generation on the back end when we're developing the services. And then our users can obviously use code gen on the front end when they're implementing the content API. But one of the things that we do with the SDK is we use that when building the SDK as well. So we are creating kind of a DSL for users to interact with when kind of invoking the SDK. And we as developers enjoy that code gen because it allows us to kind of create these functions and we get all the type safety when developing this SDK. So it's really nice working with the kind of all the type generation. And I'm relatively new to TypeScript. I was quite hesitant, but now I've been using it for like 3 or 4 weeks, like constantly every day. I see the benefits. So if there's anybody watching that is new or kind of also hesitant to get started with using some kind of code gen or getting into TypeScript with GraphQL, the benefits are huge. And as I've recently started to work on the SDK, it just makes building this kind of DSL for users just a lot nicer. And it makes me feel safer. So that's just one cool thing that we're doing with code gen. Our entire stack's code gen. And with the SDK, it makes a huge breeze. It's a really nice experience having those when developing these new functions. So I think that's an interesting thing that we're doing. Maybe others disagree.
So someone would just run the code gen on the client, and then they would just use those to make their GraphQL API calls. And then if something changed, you would just run another. You would just rerun the code gen.
Yeah, that's one thing we see our users doing with our SDK. These are functions that we generate that call GraphQL queries in the background. If that makes sense. So there could be a function that somebody would run to create a new type in their API. And then we get the safety of writing the underlying function that makes the GraphQL request. And then we can obviously import that query that the management API has under the hood, if that makes sense. So we got full safety that the GraphQL query that the SDK will execute is safe. And then the users who implement and pass kind of arguments to those functions in the JavaScript library, that's also safe as well. So everything from user input through to the SDK, through to the management API, everything is kind of type safe back to front.
Kind of along those lines, one slightly unorthodox thing that we've been experimenting with, that we'll publish soon, is again around persistent queries, where the idea is you effectively go in and you build the queries inside of a dashboard, and then you publish to npm a npm package. And for each of those persistent queries, we basically just generate a function with typed inputs and typed outputs. So as a consumer, you don't even care that it's GraphQL under the hood. It's just a set of functions that your company has built, and you have nice autocomplete and type safety all across the way.
Ooh, that's so nice.
It's really fun. We just today we had a meeting with someone from the community who took. So we have a library called Sofa that takes like GraphQL and then generates like automatically REST endpoints from that GraphQL server. Which is nice, but it's like it gives you like, you know, usually when you want to actually like you would want to customize your REST endpoints and everything. And what they've done is they actually took and wrote like you write queries and then you can annotate them in specific ways, which then you know, first of all you can create custom REST endpoints by a specific query, kind of like, you know, a persistent query, but then makes it like a REST endpoint. You can also annotate it with all kinds of transformations and things like that. So it was super powerful and cool.
So this conversation to me is like really, really interesting. I'm really curious, like why people are doing this stuff, right? Because at AWS, we actually did the exact same thing that Sean is kind of talking about, or a similar thing where basically we talk to developers, and this is a GraphQL talk, right? Like we're here to talk about GraphQL, but think about all of the developers that have never used GraphQL. We almost kind of like started, you know, noticing after interviewing tons and tons of developers that like the barrier to entry to GraphQL, even today, like 6, 10, I don't know how many years, like whatever, I probably just completely messed it up. However many years GraphQL has been around, even now, like new developers kind of are hitting it, like a barrier to entry, and it's kind of making it harder. So what we ended up doing was basically creating a completely different API. And it was kind of called Data Store, and we basically do you know, code generation. We create these models, and you have to do all this crap. And you basically, the whole idea though is to get around teaching the developer how to use GraphQL. And we saw a lot of adoption actually in it. So like I'm kind of curious, like where you know, you're building these things, Sean. You're talking about this similar thing, Yuri. We've built something similar at AWS. Like, is GraphQL still like hard for people to kind of get up and running with, to the point where we need to generate abstractions to where they don't even have to think about it? And if so, like, you know, what do you all think is what is a good discussion around that?
We have secondary reasons for doing it that I think are maybe not really applicable to the normal GraphQL ecosystem. Like there are some abstractions that we want to achieve for some stuff we're working on. And I think oftentimes it's better if you can have the source of the GraphQL in your code in C and change the fields there, rather than having a secondary step where you go and you edit it in some other studio or whatever. So I think it's an expensive abstraction to bring in, and it should probably only be done whenever it actually makes sense for a specific team.
Yeah, same here. Like our reasons were, you know, just consumers that, you know, didn't know GraphQL or couldn't use GraphQL, or, you know, we needed to expose REST APIs, even though, and there are also some other benefits of like doing that, like operational benefits sometimes, but similar to persistent queries that you could do. But to your question, yeah, I think it's still, I guess, a bit hard. I don't know why, but it's true. I think I don't know. There's all kinds of cool things that are being done. I mean, there's this one thing that everyone don't like to talk about it, but I really like that project, is the GQLS project. I really like that project because I think it's kind of like abstracts away GraphQL from you as a developer, and I think that's the best way to use GraphQL. I mean, and yeah, there's all kinds of things to talk about it, and why But I really like that project. Like, it really makes it super easy. If that was your introduction to GraphQL, then that would have been much easier, I think, for many people.
Yeah, especially if that was an introduction to using it on the client, because I think what confuses some people is that, okay, I get it, I get GraphQL, but I don't understand how I'm actually going to use this with my tooling that I have on the client, right? But I think one of the other reasons that we've seen, especially in the enterprise, is that even though people really like GraphQL, the developer experience of GraphQL, the ability to explore the API, right, the type documentation for what you're fetching, what ends up becoming a problem is that they have just too much tooling and experience around the REST ecosystem. And especially for enterprise, that's very valuable, right? Like I've talked about this a bunch of times, but like, for example, when you have error handling and you want to get errors, people don't build their own SRE stack, right? Like, GitHub does, maybe Twitter does, right? But like everybody else on the planet is not building their own SRE stack, right? They don't have like oh yeah, we changed the API protocol and then we asked our SREs to implement that too, right? So that's not even possible. And so for them, like, for example, if I want to capture API errors, it's going to happen through an external tool that I've gotten. And now I have security compliance around it, because in GraphQL, the errors are maybe propagated in the body. And if I want insight there, that insight is going to come from an external tool. But from security and compliant purposes, I can't take that and send that data to my external tool. And it's a nightmare. Like, nobody wants to think about any of it, right? They don't, even if it's possible, they just don't want to do it. For legitimate reasons. I mean, for them, the trade-off of saying that the API exploration is easier to changing all of my infrastructure is it's not worth it, right? So one of the things that we've also done recently, again, this similar theme, is a step very similar to a persisted queries, which is to say you can self-serve your REST endpoints. So you use GraphQL as kind of an intermediate step and say, I love this API, and then convert that to a REST endpoint. And then you get exactly the data that you want, but it's idiomatic REST. That means it works with everything, all of the REST stuff that you have. So you're getting that benefit of GraphQL, but you're also just leveraging all of the existing stuff that you have around REST. And this works for like non-front-end clients as well, right? Clients that are not front-end applications that don't have a dedicated client, right? Like, it might be like another backend service or an external developer or something. So I think there are some interesting kind of trade-offs there with not being able to kind of use GraphQL directly.
I would also add, I think, so, making stuff like that, like, I don't know, generating REST endpoints, or, generating SDKs and automatically create selection sets are, things for the consumer. I would also add that, like, this is a personal opinion, but I think in the, many of the beginners are starting with Node.js when they write the server implementation. And we have seen, I think, for the past couple of years, a big stagnation in that area. And not a lot of changes has happened. And there's a lot of things to do. But to be honest, I think, I can't, I won't share it here because we're going to launch it soon, but there's something new coming up on the Node backend area.
Oh, nice.
Yeah, so if you want to, it's actually, if you're going to dig deep, then it's already open source and you can find it. But and if you want to try today, you can contact me. But yeah, it's been an area that's been a bit stagnation for a couple of years. And finally, I think we have something that makes a lot of, I think, just setting up a GraphQL server way, way easier. In Node.js specifically, unfortunately, for now, but yeah.
That's awesome. That's awesome to hear. All right. So yeah, if folks have any other questions or conversations around this idea of around type safety and GraphQL, but also around kind of GraphQL and getting kind of the benefits of GraphQL and how people are using it in the wild. If folks have anything to say here, go forth or hold your silence. No, but all right. So in that case, we'll move on to the next topic, which is by Uri on the GraphQL getting started experience, which is kind of what we've been talking about for the last 2 minutes. But Uri would love for you to kind of introduce that topic and discussion points, that you'd like to talk about around getting started with GraphQL, everything from tutorials, resources, and actual code as well.
I even forgot I raised that subject, but it's a great subject. I think it's a very important one. I think someone we talked about already, but I think I guess I raised that subject because I think I constantly think about usually when we work with like large companies and enterprises, and then we try to make our tools as flexible and powerful as possible. And we use it every day, so we kind of forget how it is to get started with GraphQL. So I think what we are not doing good at all at the Guild is, thinking, about that initial experience. So I started thinking about it a bit just on my personal time and see like how could we, make it better, because I think it's beneficial for everyone, for the whole ecosystem, to make it a bit easier. And one thing we started doing in the last year is actually thinking where the first time people are, hearing about GraphQL, where are they going? Like, where do they reach? And usually it's graphql.org. So, we just thought about that as a funnel. Like, so how could we make graphql.org a better website? Like, it's been a website that has until like a couple of months ago hasn't been touched. And it's a great website, by the way. Like the work of what everyone has done at the beginning when they created that website is amazing. But I think there's a lot of improvements to do, and I'm trying constantly to think, okay, so they're reaching out from there, where are they going next, and how could we make that experience better? Like maybe it's the toolings themselves that could be easier, but also just the path, like how could we make graphql.org better? Can we direct people to the right tutorials and the right places from there? Things like that. So I just wanted to hear your thoughts about the whole thing. And now basically graphql.org is open for business again. So everything you can say here now can actually we can actually go on and do it. So yeah.
Just for folks who don't have Uri and the folks at the Guild have been, along with other people, pitching in quite a bit on the GraphQL.org website, helping update that and revamp that. So, interesting things that you'd like to see there and stuff like that, please do feel free to bring that up with Uri. But yeah, otherwise, we'd also love to hear kind of the specific maybe onboarding and learning experiences that you folks have been instituting along with your teams. As they're getting started with GraphQL, things that might be GraphQL like generic or even specific to your particular API and your particular use case. Are there things that you're doing specifically, or kind of just like it's simple enough, go learn it yourself types?
So
if nobody takes this, yeah, go ahead. Thanks.
Yeah, I was gonna say I'm not like doing anything specific, but one place that I've noticed that a lot of beginners get like stuck and burnt and like really they have a hard time with is GraphQL clients. Like I think the ones right now that they start with are very confusing. Like they usually default to Apollo and it just hurts their brain. Like especially when they try updating after a mutation, like that's where you see 95% of people just like quit GraphQL. Like they just, I think that's the biggest pain point I see with like, at least from the front end of people trying GraphQL, is the clients are much more confusing. And I feel like Apollo has gotten more confusing, and that's kind of the default that everyone starts with usually.
Yeah, I've seen a lot of people just say no to GraphQL for mutations. They're like, GraphQL mutations, I don't buy it. We're going to just keep using REST for our everything else. And reads are great on GraphQL, easy to explore. You can fetch what you want. Let's use GraphQL for reads. We're not even touching anything else, right? So this works out if they don't have to manage a client-side cache and they don't need any particular tooling. But yeah.
The biggest onboarding hurdle that I've seen for developers is that everybody who's starting with GraphQL already has the knowledge of REST APIs, and the switch from the server-driven architecture to completely and fully client-driven model is very hard to get your head around, especially because there are, I wouldn't necessarily say holes in the spec of GraphQL, but ambiguities. One thing that I know was driving everybody insane on my team when they were starting to look into GraphQL is the error handling, right? GraphQL spec, for a reasonable reason, says we don't want to be opinionated about it. If you want to put the errors into your schema, great. If you want to throw errors, great. You can do either one. But this ambiguity for the beginners is very painful, because you don't know what's the benefits of each approach, and you can't make up your mind easily without knowing those benefits. And the whole, when you compound that on top of the client is completely in control of the data that it gets, it becomes even much more complicated, because now if the client is fully in control, how do you handle errors? You don't know what errors might come up, right? So those kind of ambiguities in the spec, in comparison, like in addition to the client-driven model, is where I've seen majority of the problems of people getting their head around kind of GraphQL approach.
Yeah, I would love to bring up a point here as well. I spend a lot of time on Stack Overflow, and what I notice is that this assumption that people just go to GraphQL.org because they want to build a GraphQL API or maybe switch to GraphQL, I think that's not necessarily true because of the success of GraphQL. A lot of people actually encounter GraphQL in the wild. They encounter GraphQL because they have to use the GitHub API, or because they want to use Hasura, or maybe because at their workplace they use the GraphQL API. So, and then often a lot of questions, you notice that people don't really deeply understand what GraphQL is because they confuse GraphQL with SQL. They think that GraphQL works everywhere the same. So they ask, how do I fetch a user on a GraphQL API? But the answer then has to be, well, what GraphQL API are you even using? And I think that's something we need to also get better at communicating. And I've been thinking about a lot is how can we actually, communicate that and give them the right places to entry? Because if everyone would go to GraphQL.org and first learn what is GraphQL really about and how does it work, that would be a straightforward path. But I think most people somehow find GraphQL in the wild instead and need to suddenly deal with GraphQL as a technology.
But I do think it's also very similar to like learning anything else, right? Like, for example, the first time you encounter a REST API and you think that like get or post or whatever is like frozen somehow, like the wire will not transmit this request if I don't have a get there, right? And then you realize, wait, actually it's just a bunch of characters and I can have my own method called like Tanmay. And I can say Tanmay is a method and this is the URL and I can do whatever I want, right? It's like an understanding, like a layered understanding that builds gradually about what you have, right? And I feel like the REST-ish ecosystem has done better at being kind of flexible and allowing you to kind of peel back the layers of the REST onion to a degree that none of us actually know what the actual HOS REST spec is. But we still talk about REST as if we're all like, yeah, we're REST. But I mean, it's just a lot of layers, right? Whereas with GraphQL, it's kind of like this initial hump, and it's not like too many layers to it, right? It's like it's a slightly, I don't want to use the word inflexible, but inflexible spec compared to say the way REST is, right? Because REST isn't really even a spec.
I think maybe a better analogy might be with Git, where Git is like incredibly simple with lots of pieces. But if you have to understand all of those pieces, it's very daunting. And like none of us typically think of like, I'm creating nodes and trees and refs and I'm pointing the refs at all these other nodes. Like I have a much better way of interfacing with it. And that's kind of like GraphQL is made up of, I think, principally sound small pieces that can be composed together in a really nice way, but it is asking a lot to have to understand all of that up front. Versus with REST, again, it's just like it's a very blocky granularity where it's like, look, here's an endpoint, you make a request to it, and maybe if it doesn't work, try a different method. Like no one, when they first are learning REST, is like, okay, well, let me open up the HTTP stream and read the characters from the header, right? Like that's just not how people think about REST. They just think like there's a URL and I call it. So I think it's GraphQL does kind of force a lot more upfront, which is a challenge. And there isn't like necessarily an equivalent of like a really nice GitHub clients kind of, or Git clients, you know, that simplifies this to a higher granularity.
Another thing on that too is REST is pretty similar when you go jump from API to API. Like everybody has a user's endpoint, you have a me endpoint, you have very similar constructs between the two. In GraphQL, it changes pretty differently from graph to graph depending on how they want to express their ecosystem. I mean, granted, there's still a few very similar things, but for the most part, it's very different in GraphQL than it is the RESTful world when you jump around.
Yeah,
We've been encouraging.
Go ahead, Shruti. Hey.
Hey, we've been encouraging folks to first try out Playground and Graphical so they can kind of see what GraphQL looks like. And then they're kind of like bought into that experience, like, oh, I can like fire a mutation and I can see all the data back. So then we encourage them to go and try out, look at the documentation either in graphql.org or maybe open up like a tutorial that they are interested in. So for example, like Udemy has really good ones, Egghead has really good ones. So you kind of like first show them what GraphQL is. So they can like try and experiment with it. And then we kind of show them, here's some tutorials you can check out. And then we encourage people to consume a GraphQL API first. So GitHub has an open GraphQL API. Encourage them to like consume a GraphQL API by maybe like making a client that just like fetches information. And then once you're comfortable with that, then you can go ahead and create your own GraphQL API itself.
Yeah, no, I think that makes a lot of sense. One of the other challenges that I've also encountered is that it's not the developers who have a problem understanding GraphQL. It's getting the architects and the other people to sign off on saying yes to GraphQL. So it's like developers are totally fine with. I mean, and you know, I think we're also going to just see a whole new generation of developers who are born with GraphQL, maybe, right? It's like the first application that they built happened to be a GraphQL API, so they're not even. There's no baggage. Right, it's just the first thing that they learned. Like so part of the struggle is like an older cohort trying to understand this new thing, and that's especially worse with architects because they're just like, no, control to the client, no, I don't get it, we're not going to do it, it doesn't make any sense, right? So they don't even want to kind of get beyond that. So I think there's an organizational challenge also in not just the developer adoption of GraphQL, but also like the organizational adoption of GraphQL and a kind of a realistic assessment of challenges there, right? So that's another challenge that we've encountered quite often in the wild. But I don't know if again people have seen success there.
Yeah, I wanted to
go ahead, Naomi.
Oh, I was going to piggyback kind of off of what you said about people, not maybe developers who have had issues. We definitely. We've had a GraphQL API since 2016, but our support team is in particular a team that has struggled with, we get support tickets for people who are struggling with an API or it's not working the way they expect it in GraphQL, and trying to like ramp up support people who maybe are more experienced in REST to then support questions in GraphQL. And I think especially in the GitHub GraphQL, which the schema is enormous, trying to figure out, how many levels deep you need to go to get something, and understanding how like a graph, maybe not coming from, a super technical background, not being a programmer, understanding how a graph is created and how that relates and where you can get things off of that graph, I think can be confusing for new people stepping into GraphQL.
Yep, no, that's very true. Shruti, you were saying something.
Yeah, I was going to say, like when you mentioned architects, that actually reminded me of one of the comments that I heard from one of our architects, which was, she mentioned that like it makes fairly a lot of sense. Like when you think of using GraphQL for a mobile client or like for a mobile application, but then it doesn't make too much sense when we are using web applications. So that was like an interesting concept. It took a little bit of time to like convince that architect that this is, you know, good for both mobile and web applications. I think maybe because like GraphQL was built for the mobile first approach.
Yeah, that's also very true. I think increasingly I've started to get this slightly, well, not started to, but I've had this suspicion, and it's kind of bearing out a little bit more, which is that the envelope or whatever, that margin where GraphQL is amazing is actually quite small and specific. And that, I think, is a little bit counterintuitive for people who are coming from a REST background, where there is no such thing as REST, and I can do whatever I want over REST. I can send you binary data, JSON, like it's whatever, right? But with, and I can use it for web clients or mobile clients or IoT or whatever, and REST works with everything. I don't have to think about anything new because it's just so pervasive. Now, suddenly this GraphQL thing comes along, and by the time you weigh all the pros and cons, you realize, okay, only private APIs, useful only where I care about network transfer, only useful for internal to external communications. Internal to internal, I might as well use something else because I don't have to pay for network. And then you realize that it's only JSON. Whatever I can express in JSON, nothing outside of JSON works. So then suddenly you realize that, like, and then of course, like the trade-off that you're giving all of the control to the client, the trade-off of all of the new tooling, you realize that the place where GraphQL is 10x, 100x is very small. And I think that's also confusing for architects, because they're like, okay, maybe we use GraphQL for this use case, but then what happens to the other stuff? Do I keep maintaining my REST API? Do I maintain that forever? Because I know that's not going to go away. And I think that also is a big, like, genuine problem that we've seen. I've would love to hear, like, from Uri and Naomi on, like, Uri, how you've seen like GraphQL and REST simultaneous adoption, people think about it. Naomi, how like it works internally for you folks, because you're maintaining a GraphQL and a REST API, and I'm assuming the REST API is not going away anytime soon. So, how do you handle that?
Yeah, I mean, REST is not going away, and not anywhere. Not, it's going to be there forever. And I think for us, it's just what we learned is we just use it when we just use GraphQL. So it's two things that are combined together. One is like we just use it when it makes sense, and we can show benefits really quickly, and people are mostly where people are open for it. I think that's the most important thing. Sometimes people are just not open for it, so we're not going to force them to do anything. But that actually worked surprisingly in all kinds of weird places. So, we started using GraphQL and see benefits for service-to-service communication suddenly in all kinds of weird places that we didn't think about before, or just on the client side, or as managing webhooks, which actually underneath the hoods are GraphQL subscriptions, and then we generate webhooks from them, like all kinds of. So just by thinking about it as a, maybe going to the basics and thinking about it like as a function that you send a query to, and like an executable schema, suddenly like you can run that function anywhere. And then when when you just think, oh, here is a place I could use, I don't know, something that will, get me a query in the shape that I want, suddenly you find all kinds of really weird places to use it, and not necessarily the classical place of like mobile devices and saving off the network. But yeah, it's mostly around. I mean, when I think about it, I just think about there's a function call and there's a query call, and a function call is like when you call a function, or when you call a gRPC or a REST endpoint. And then there's a query call like SQL or GraphQL. And when you think about that in that kind of way, suddenly, first of all, you care a bit less about, okay, you can use a function. You don't have to send a query. That's fine. If it's just simpler and nicer. But, in places where you get a query, which means that the provider gets more information, and maybe that information is valuable for the provider. Maybe the provider can, it can help the provider, for example, deprecating things. from the service to service communication, suddenly services were very happy to understand that they could deprecate some things, even though they're not being, queried by mobile devices or something like that. So just for me, just this way of thinking about it was very easy and made us kind of like build all kinds of weird tools that worked for us.
Makes sense. And Naomi?
Yeah. So we have a REST API, a GraphQL API, and then the Rails app. And then we have consumers of our APIs, the desktop app, the mobile apps, and CLI internally. So our experience, there was a time in GitHub history where we were really excited about GraphQL and we wanted to back everything with GraphQL. So Rails would call a GraphQL query, REST would call a GraphQL query underneath the hood. And so GraphQL was kind of this like source of truth. So that, because we have so many different places where we do things, we wanted it to just all happen in one place. So you only had to make a change in one place. You just changed it in the GraphQL API. And then the Rails app would do it correctly. The REST API would do it correctly, et cetera. That didn't scale very well. But we did do it for a few years, tried to, update some of our legacy stuff into that. But ultimately, like what has been communicated here is, GraphQL does some things very well and not everything really well. GraphQL and Rails views do not work well together. You do not want to be mashing GraphQL queries into your Rails views, especially with active records. So those were some lessons we learned. But we use GraphQL to back our mobile apps. And so I think our GraphQL API has definitely matured since the release of our mobile apps because we have invested a lot more time into making them. And we definitely have a big focus on making our APIs public, because, I don't know if that answered the question.
No, that does. That makes sense. I mean, the summary is I think if I understand correctly, it's basically saying that GraphQL is already going to be very useful for GitHub internally in the web, mobile assets, whatever, right? Like on that application. It also makes sense to expose that publicly if the cost of doing that is not terribly high. And like whoever is using that GitHub GraphQL API, let them use it. But the REST API is an asset and is a team that is also just maintained and looks like it is going to be maintained going forward. So there may or may not be a little bit of duplication of work, but that just is.
Yeah. We actually, the REST API is, our desktop app is backed by our REST API. So, I mean, desktop, I believe, is an open source project. So,
got it.
REST isn't, and our enterprise, I think enterprises tend to generally use REST more than GraphQL.
Got it. Makes sense. Cool. All right. So yeah, folks, we've entered into the closing stages of our conversation. If anybody has any particular questions for each other, please feel free to go ahead. But just going by the theme of these things, whenever I ask you folks something, there isn't. So I'm just going to say we're done now. No. But in seriousness, though, if you folks do have something, go for it. We have a few minutes left. But otherwise, it was super nice having everybody here, and it was great to chat. And we'll be posting a summary of the conversations and making that available. So that will hopefully be a useful asset as a quick notes. And then, of course, this recording is going to be available so that other folks can benefit from it as well. But otherwise, that is a gradual close to our first GraphQL Contributors Days of this year.
Indeed, as Tanmay said, we'll write up a quick summary and share it. The video will be made available via the This.Dot team. Thank you, Tracy, Anne-Marie, everyone at the This.Dot team for the work that you put into making this happen. It's interesting. So I look after community work, and a lot of people ask me all the time, like, what is GraphQL? Sort of what we were talking about at the end there. To me, GraphQL is the 20 people who got together on this call to talk about making tech easier for people to use and to consume. These times are meaningful, they're useful, but they're also a sacrifice of time. And so literally, it was counting, 20 of you spoke and contributed, and that matters, from Ash's topic to Ryan talking about type safety on down the list. So thank you, not only for the folk who helped put it together, but for all of you coming together to make this an interesting and at least for me, quite useful 2.5 hours of time.
Yes, thank you everyone for coming. And, you know, shout out again that this dot is hiring. I feel like we're hiring every single day, but we just had 3 new people join this week. So if you want to come work for an awesome company working on stuff like React and GraphQL and contributing to open source with events like this, definitely message me on Twitter at LadyLeak. And yeah, thank you everyone for coming.
All right. Bye. Bye, everybody.
Thank you very much.
Thank you.
Bye, everyone.